So this x is negative natural log 4. And we need to determine now the y function value when x is natural log 1/4. So y equals e raised to natural log 1/4. Anyone remembers what happens now? It's okay if you don't, I'll explain. Does anyone remember the answer?
I'm not sure.
Okay, let's talk about it. So leave it alone for a moment. There is one other property of exponential log situations. That is this. A raised to log base A of x is x. As long as this number and this number are identical, and there is nothing else in front, just 1, then the answer is x. For example, 5 raised to log base 5 of 13 is 13, because these two are the same. And I can show you where this comes from. I can prove it to you if you want.
I feel like I've seen that before.
Of course, yes, yes.
So the answer would just be 1/4.
Correct, because this is already known to be e, right? Since these two are the same. If I change this into 5, the answer is not 1/4, because this base and this base are not the same. So the answer in this case is indeed 1/4. So I go back here and I replace y1. So here's the equation I have now. I have, am I recording? Yes, I'm recording. So y minus 1/4 equals 1/4 x minus natural log 4, which will be plus. So I have y minus 1/4 equals 1/4 x plus natural log 4. So I distribute and move 1/4. So 1/4 x plus natural log 4 over 4. I cannot do anything to that. And then plus 1 over 4, and that's the equation of the tangent line to the graph of e to the x parallel to the given line. Is that clear? So if you'd like to mute your background so we don't bother anyone. So you hear only me, I'm sorry for that. There is a part B. Any questions on this problem before we look at part B? I have to put my keyboard away. It's in the way here. Any questions on this? What page was it? I closed my book. It was on
266.
266, thank you. Okay, is this clear? Any questions? So there is nothing you can do here. If you'd like, you can write it as natural log 4 plus 1 over 4. It's the same thing. So this is the slope, x, and this is the y-intercept. 0, comma, natural log 4 plus 1 over 4 is the y-intercept of this line. Okay, part B is asking us to find an equation of the tangent to the curve of the same function that passes through the origin. I have to shut the book because it's just so big and occupies a lot of my desk. Okay, so this time we have this scenario. This is e to the x. So we want to determine the equation of the tangent line to the graph of e to the x that passes through the origin. So we are asked to find the equation of this line. And it passes through the 0, comma 0. Okay. So how do we proceed? Any suggestions on this? Any suggestions?
I don't know. Would you?
You want me to read the problem one more time? Let's read the problem one more time. Find an equation of the tangent to the curve of e to the x that passes through the origin. So let's denote this point by a comma b. And the slope of this line can be determined in two different ways. Give me one way and the second way.
The change in y over the change of x.
Very good. Which means b minus 0 over a minus 0. That's one side. What about the other possibility? For the slope. F prime of
P.
Right? The function value, the derivative, evaluated at a. Is that clear?
Yes, I understand it.
Right? Because this is the function e to the x, and if I want to determine the slope of the line at the point P of coordinates a comma b, the slope of the tangent line at this point, I have to find f prime and plug in a. So p prime of a, since p prime of x is e to the x, this will be e to the a equals b over a. Any questions so far? So then I have b cross multiply is a times e to the a. So for now I know that point P has coordinates a e to the a comma b.
Is that the answer?
No, we're asked to find the equation of the line, right? We're asked to find the equation of the line. So then y minus y1 equals the slope times x minus x1. The slope is b over a. x1 is a, and y1 is a e to a. So y minus a e raised to a equals b over a x minus a. So let's see, I'm distributing. So b over a times x, b over a times a will be minus b, and then plus a e to a.
Shouldn't y be equal to e to the a because b is equal to a e over a e to a?
So b equals a times e to a. So
Right.
the coordinates of p will be a, and b is a e to a.
Right. So in your final thing, your final equation for y, couldn't you substitute b for a e to the a, and then you could take
Yes. Yes.
Right.
So I was just yes. Okay. So I thought there was something that you wanted to correct that.
Oh,
here.
I'm
Oh
sorry.
no.
I didn't mean
Sorry.
that. Sorry.
Very good. So that will be our next step. So if we do that, let's see what happens. So b replacing b by a e to the a will give us y equals e raised to a x, and b and this will go away. Right? So negative b plus a e to the a, these will be 0. And if we set this equal to e to the x, that's actually, y is the same to, it's equal to e to the x. So that's why the equation, in this particular case, you can just leave it as is, as e to the a x, right? So that's the equation of the line that is tangent to the graph of e to the x and passes through the origin. So we replaced b by a e to the a, so that's e to the a times x. And these two are the same. And when I combine this with y equals e to the x, then let's see what we get for that. E to the a, because the point is on the line as well as on the equation. So the point P is on this as well as on this, mandatory. It's a point that belongs to the tangent and to the graph. So e to the a times x equals e to the x. So I have to solve this equation for a. So let's see how we do this to find a, because that's the only variable that we don't have, the only unknown. So x equals e to the x over e to the a, which means x equals e to x minus a. I have no way of solving this, so I have to basically, no, I don't want this. I want e to the a to be e to the x over x. And let's see how we solve this, because we want to solve for a. I don't need this. So in order to solve for a, I will have to apply natural log to both sides. So a equals natural log e to the x divided by x, which I can change into natural log of the top minus natural log of the denominator and put x in front. So this is x minus natural log x. So that's the only way. So then the equation of the tangent line is e raised to all this times x. I can simplify a tiny bit. So y equals x, I'll put it in front, e to the x times e to natural log 1 over x. So I can change it into 1 over x. And I'm going around in very nice, interested, so y equals e to the x. Because when I replace this by 1 over x, I will cancel the x. So as a conclusion to the problem, I would not do just anything else, but this will be the equation of the tangent line. It's a very interesting situation. So y equals a constant, which is e to a times x. I don't see. Yep, this is the equation of the tangent. There is nothing else I can do here.
Okay.
And which really means, I want to graph this for a second. This is e to the x, And it's asking us to find, so at this point, this is the tangent. Now this continues. So at this point, I will have a different tangent. So it really depends on where the point is. So I can't say there is a unique tangent. To the graph, because the graph really has more than one tangent. I can't, and we can do this, it's an interesting situation. So we can do this with a graphing calculator. I don't know how we can see it. So e to the x. And then I'm going to just make up an a. So I'm going to say just, let's say e squared x. E squared x. Okay, and I'm going to graph both. And let's see, use a viewing window. I'm not sure where it's going to cross. So I'm going to use the standard. I'm going to use standard for a moment, 6. Here comes e to the x. And here comes the tangent. It should, I don't like it. That's not a tangent. Okay. So that was our point. We want the tangent to go through the origin. So b minus 0, a minus 0, that's correct. F prime of a, that's correct. F prime of a, it's e to the x of a equals b over a. At that point, for a, we have, sorry. Is that what you were saying, Derek?
I did not say anything.
No, you corrected or somebody corrected something and I should have gone back. Okay. So the point is e to the a, not a, right? Sorry, my apologies for that. So this point has coordinates. Oh, no, that's correct. Okay, sorry. So the point is a comma b, which means a e to the a. Of course. So P is, when x is a comma e to the a. So we got that b was this, but it has to equal. So b, which is a e to the a, e to the a has to equal a e to the a. So a equals 1. Okay. So that's what happened. So please do not correct this. This is correct. That is correct. Okay, that's what happened. So a is 1, so y equals x. That's the equation of the tangent passing through the origin. Thank God for graphing calculators. Okay. So that's e to the x, and that is the tangent passing through the origin, and it does not, it's not my tangent. B equals, so e to a, that's correct, equals b over a, that's correct. B equals a e to the a, that's correct. I'm just going to check to make sure I'm going through everything. So then y minus y1. Okay, so I'll have to redo this. So we had y minus y1 equals the slope times x minus x1. So our point P was a, comma, e to a, P, a, e to a, correct. And then we got that e to a is indeed b over a. That was correct. B is indeed a, e to a. That's correct. So when we set these two equal to each other, a is indeed 1. There is no question there. And then y minus y1 equals the slope times x minus x1, where x1 is 1. The slope is b over a, but since a is 1, b is e. A is 1, B is E. Okay, got it. So the point is then 1, comma, E to E. That's it. Okay. And the slope, one more time, the slope is B over A. B is E. A is 1. Okay. So then y minus e equals e x minus 1, e x minus e, but plus e, these two will go away. So y equals ex. So that's the equation of the tangent. Okay, sorry about that. When I see 3 minutes left, it's not nobody's fault. I go from, okay, so this is E, insert an E. I just want to clear that because I want this E, EX. Okay, so finally I want a graph. Okay, and now this line has to go through the origin and it has to be tangent. Thank you. So it is tangent at the point 1, comma E. So if I want to check that, I go to second and table set. Okay, so all I want to put in is 1 for both functions. Once I put in 1 for both functions, I have to get E on the second for both of them. 2.7183, 2.7183, because that's where they intersect. So my error was here when what did I do? I did not set these equal to each other to find A. So that was okay. Actually, this was correct, but A is 1. So I should have found A first, and then the answer would have been correct, EX. I'm going to post this is, but I'm going to cross out what is not relevant. So all this is good, but I needed to find A. So this is not relevant. I'm not going to put this in. This is not relevant at all. So that's 2. So that's 11. Well, thank you for bearing with me. Sorry about that. Thank you for being patient. Yeah, that was the issue here. So this is A, indeed. There was no mistake here. So this is A, comma, A, E to A. But that was what I needed to find A, so it was just EX, exactly what we got. In a slightly different way, but that was it, with A equals 1.